For this tutorial, we're going to start off by learning another way of calculating theoretical probability. So here with example 4, they want us to answer the questions using a Venn diagram. So here's a blank Venn diagram at the moment. Let's find out what the situation is. So out of 100 young adults, 22 go to school full-time, 39 work full-time, and 32 go to school and work full-time. So before we start answering the following questions here, let's fill out the Venn diagram using this info they gave us. So within this rectangular area, we're going to have all 100 students. Now they may be placed in different areas depending on what category they fit into. So first of all, we have this circle right here, and we could specifically assign that to be young adults who go to school full-time. And then for this other circle, let's label that for students who go to work full-time. And now you see where they intermix here is where we'll have students that both go to school and work full-time. So first let's focus on students that go to school only. Out of the 100, 22 go to school full-time. So we'll put 22 right there. And then now let's focus on the young adults who work full-time. So out of the 100, there are 39 who only work full-time. So now we still need to find out how many young adults do both school and work. So out of the 100, 32 go to school and work full-time. So now, if you notice, if we add these up, 22 plus 32 is 54, and 54 plus 39 is 93. Now that's only 93 young adults. There are 100 in this example here. So that means 7 of these young adults don't do school or work. So they'll be outside of those areas. So we could just write a 7 right here. So there are the rest of this empty space. They don't do school or work. So now that we've made our Venn diagram, let's use it to answer the following questions. So if one of these young adults is chosen at random, what is the probability that the young adult goes to school? Well, for young adults, there are 22 who only go to school, but there's also 32 who do school and work. So we need to include both of these, because all these students right here do go to school. It doesn't matter if some of them go to work as well. They just asked us how many go to school. So there's going to be the 22 plus the 32 out of the total of 100 students. So that gives us a probability of 54 out of 100. Now again, we could reduce that if we'd like. And if we do that, we get 27 out of 50. Or we could write it as a decimal or percent. So 0.54, or move the decimal over twice to get 54%. So if a young adult was chosen at random, the probability that the young adult goes to school would be a 54% chance. Now, what's the probability that the young adult doesn't go to school? Well, these people who only go to work don't go to school, and also these 7 people who don't do school or work also don't go to school. So we would have this 39 plus 7 who don't go to school. So 39 plus 7 over 100. And that would give us a probability of 46 out of 100. Now again, we could reduce this if the fraction's reducible, which it is. And that gives us a 23 out of 50. So that would be our probability for this case. Now for the final one, they want to know what's the probability that the young adult who's chosen doesn't work or go to school. Well, all these young adults right here either do school or work, or both. So we're just left with the 7 here who don't do either. So there'd be a probability of 7 out of 100 young adults who don't do school or work. And again, we could change that to a decimal or a percent. So that would be a 7% chance that the young adult doesn't work or go to school. So that about concludes the section on theoretical probability. Now let's take a look at the last type of probability for this tutorial, and that's geometric probability. So here with example 5, if you threw a dart at the given shape, what's the probability that the dart would land on the orange region? So first of all, we have this shape here. It has different colored regions. And even though we don't necessarily know measurements, we could see relative sizes. So for example, this orange section here looks like it's about a quarter of the entire circle. So if they're asking us what's the chance that the dart would land on the orange region, well, it would be about 1/4 of the entire shape. Now what about the green region? Well, here, if this was 1/4, it looks like green is half of that. So with this one green section, it would be half of this 1/4 here. So if we took a 1/4 and cut it in half, we'd get an 1/8. So the probability of hitting this green region when we throw a dart would be 1 out of 8. And now for the final question, what's the probability that the dart will not hit a yellow region? Well, right here, this yellow region looks like about a 1/4, and then this yellow region looks like about an 1/8. So if we add a 1/4 and an 1/8 together, we need to get a common denominator. So the 1/4 we could turn into 2/8, then add the 1/8 to it. That gives us a chance of 3/8 to hit the yellow region. They're asking us to not hit the yellow region. Well, if it's a 3/8 chance to hit it, then that means there's a 5/8 chance of not hitting it. Because what's left over from this 3 out of the total of 8 possibilities would be 5. So we have a 5/8 chance of not hitting the yellow region. And that about sums up geometric probability.